Number 3, we're going to start with the cube root of 16, a to the 4th, b to the 10th, y to the 6th power. Start with a similar example. Each one of these, you should notice, has an index of 3, or the third root, or the cubed root in each one of these, which means I need 3 numbers to multiply in order to take the root of it. And so let's actually think about 3 numbers that multiply to give us 16. And I'm going to do that work off to the side. And I know that 2 to the 3rd power is 8, and that 3 to the 3rd power is 27. Why that's important is because the cubed root of 8 is 2, and the cube root of 27, therefore, would be 3. Here's a problem, though. Neither one of those numbers shows up in this problem. It's a 16. So I can't use 8 and I can't use 27. But remember how we break these down. We can actually break this down to include 8. All right, so let's actually take the cube root of 8. And since 8 times 2 is 16, we can factor this down into 8 and 2. 8 times 2 is 16. I'm keeping that that root out front. And now in that way, one of these now is a perfect cube. So I've factored it into a perfect cube. And so let's actually think. We know what the cube root of 8 therefore is going to be. It's going to be 2. And so this is going to come out front of our cube root symbol. The 2, since it's not a perfect square, or a perfect cube, is going to stay inside. So this became 2 and this 2 stayed the same. Now I've got to figure out what to do with the inside variables. Well, the index tells me that the only way that we can cancel this out is if I get a group of 3 and then cube root it, that will cancel it out into a regular number. So we're going to look for perfect cubes on the inside. We're going to break this down into groups of 3. A to the 3rd times a, we'll even call that a to the 1st. And then how many groups of 3 for 10? 1, 2, that gives me 6, 9, 1 left over. How many groups of 3 for y? Well, let's see, I got just 2 because that'll give me 6. And so now I've kind of factored my regular number. Now I've got groups of 3. Let's actually count how many groups of 3 that we have. We have 1 group of 3, 2, 3, 4, 5, 6. So remember that in each one of those, if I cube root a cube, that just gives me the same thing. So this is just going to turn into an a out front, a b, and a b, a y, and a y. So if I rewrite this, I'm going to have a 2 out front with an a, b to the 3rd, y squared. Why? Because those came from the groups of 3. If I have a group of 3 with a cube, it's a perfect cube root. Now, let's actually keep that root of 3 on there. Let's see now what remains on the inside. On the inside, I got a 2, an a, and a b. None of those are perfect cubes, so therefore, there's my final answer.